There has always been a language barrier between hard of hearing individuals and hearing individuals, which is one of the biggest reasons why I worked on this project. But now, with the rising development of AI and machine learning, this barrier can be overcome more easily. Hello, my name is Amogh Khaparde. I live in California, and my mentor's name from Polygence is Clark Hoshcraft. In this project, I created an engineering solution to help ease communication between hard of hearing and hearing individuals, especially when there's no human translator present. A human interpreter can take a lot of money to hire, and hard of hearing individuals who might not know English may have trouble communicating with hearing individuals. To work around this issue, one can use machine learning applications to translate ASL fingerspelling or gestures into text. One such application is McTranet, a deep neural CNN ResNet 34 model that uses webcam input for ASL fingerspelling and converts that into text. And by researching models similar to this, I realized that CNN models are actually the best approach to solve this problem, as they are efficient in terms of they can run on less computer resources and also take less time to train. As for my own model, the ideal goal for this model's accuracy is 80% or higher, and the loss should be less than 0.5% or 1%. In addition, it should be able to run on devices with less computing power, as I mentioned, unlike McTranet, which actually took more computing power while being extremely accurate. We want to balance of those. I created an innovative application that uses this ResNet 18 deep convolutional neural network model to predict ASL fingerspelling from camera frames, coupled with a Chat-GPT system that takes all the predicted labels and corrects spelling and grammar, and even any misclassifications made by the CNN model. And then it sends that to the text-to-speech system that I created using the play.ht API, which further smoothens the language barrier, since it would, from the user end, it would just be going from um, whatever gesture the hard of hearing individual wants to present to the camera, straight to speech for the hearing individual to listen to and understand. So in order to go about doing this, I use my MSI gaming laptop with an NVIDIA RTX 4050 GPU and i9 13 Gen CPU. Um, I coded this in Visual Studio Code, and I coded this in Python 3.10.6. I use PyTorch's machine learning framework in order to build this model. And in addition to train this model, I use PyTorch's ResNet 18 ImageNet V1 pre-trained weights. Um, as for the webcam, this webcam is actually built into this laptop, and um, it has 1080p resolution. To start out, I created multiple files to make the model, make pictures, and run the ChatGPT code, uh, and the text-to-speech code. In addition, there was also a file for uh, augmenting pictures from within the training dataset and the testing dataset. And I created a app.py file that centers the whole application around this specific file, so that um, there's a more organized way of handling information that goes through file to file. Um, to start out, I made two data sets. The training data set, which was approximately 300 images per alphabet class, and the testing data set, which was also 300 alphabets, 300 images per alphabet class. And however, for the training data set specifically, I augmented each image 5 times with rotation, random brightness, and random contrast, which ended up equaling to around 1,500 images for alphabet class, which in total made 40,000 images or 45,000 images for the training data set only. And uh, I loaded both datasets and trained a ResNet 18 model using those pre-trained weights, and I trained this on 15 epochs. After this, I saved a confusion matrix and accuracy loss graphs, and I evaluated my model to test if the accuracy was above 70 or 80%, and the loss was below 1% or so. In addition, I checked the confusion matrix to see that there was no issue between specific classes. Um, and if the previous steps were fulfilled, I could move on and finish up my project. Otherwise, I would have to keep testing. After creating a model, the accuracy was around 97% and the loss was 0.13%, showing that the model had many true positive, and this was actually confirmed by the confusion matrix, as there's a dark diagonal line going through the matrix. However, the model struggled on some letters, such as M and N, where the hand shape of both of these symbols are actually very similar. So I hypothesized that maybe background interference or any other noise other than my hand could be influencing the predictions of these images, the predicted label of these images. So I made another file, which I showed previously, to crop out each the background of each image and create a new model. The first model lacked the ability to distinguish between two classes such as M and N, but however, the new model had an accuracy of 98.5% and a 0.35% loss. So the model did slightly better with the M and N issue, and it turned out to be a major improvement because the background interference was removed, proving my hypothesis that the noise from the background detrimentally affected the performance of my previous model. And I believe that the background crop will work better with other individuals since the model only focuses on the hand, which allows it to be less biased and work with more people as well. This project has a long way to go, and for further research, I could try to make more intuitive gestures for the model, such as hello, or so that it's not just the alphabet that this model can recognize, in order to increase maybe efficiency of or user ease of access to signing out messages into the model. And I can even try using data sets such as the Chicago fingerspelling wild data set, which is a very, very large data set of fingerspelling images across deaf social media and parts of the internet that can help, in my model at least, with more varied training data and thus give us a more or a less biased model, which can work with more people. Here are my sources, and thanks for listening.